This is part 2 of our section 4.4. It's on side, side, side. Which are the coordinates of the vertices of a triangle congruent to triangle PQR? So the first thing you have to do is figure out how long these sides are on triangle PQR. It's pretty easy to see this is a horizontal segment and this is a vertical segment. You can definitely count those lengths. So that horizontal segment has a length of 4. The vertical segment has a length of 3. Also, since this is horizontal and this is vertical, you know this is a right angle. And I don't know if we've talked about this yet, but if you have a right triangle where legs are 3 and 4, the hypotenuse is going to be 5. And if you didn't know that, you can't count this distance, but what you could do is use the distance formula to find the distance from P to R. So we have a 3, 4, 5 right triangle. What you need to do is find which one of these options is a 3, 4, 5 right triangle also, because if you can find a 3, 4, 5, that would have to be congruent to this triangle because of side, side, side. Okay, so I'll use a different color here and I'll plot the points for the different triangles. -1, 1 lives here at point R. -1, 5 lives here. And -4, 5 lives here. So here's your triangle. Again, it's a right triangle, which is a good start. Now, if we can figure out that this is 3 and this is 4, then that's the match. This is 3, it's horizontal. This is 4, that's vertical. So this must be 5 as well. So this is a little bit easier than I was expecting, only because this first option was our answer. Now, what you should do is you should check the rest of these if you had time. If you're on a standardized test and it's timed, maybe you don't have time to check every single one of these. So if you are certain, maybe going with this is best. But if you have time, you probably should consider the rest of these to make sure you didn't make a mistake here. But these two triangles, the red one and the blue one, are congruent because they each have lengths 3, 4, and 5. That's congruent triangles by side, side, side. This is a great example. Solve a real-world problem. Structural support. Explain why the bench with the diagonal support is stable, while the one without the support can collapse. Well, this is the same photo, just so you know. I just kind of drew over top of this and drew a support on here. This bench is definitely more stable than this one because of the support. But why is that? Think about shapes. The shapes over here in this bench would be two triangles. And triangles cannot change shape. If it's a triangle, and we just use that example from the last one, and let's just say you have sides 3, 4, and 5. It's impossible for this to shift into another triangle. Because if you have sides 3, 4, 5, it makes one triangle. That's what side, side, side means. You can't make a different triangle with this. So if this triangle stays together, it's not going to shift into another shape. That's not the same case with a four-sided figure. This four-sided figure could stay together as a four-sided figure, but it could shift into a different shape. It could shift from a rectangle into a parallelogram. And they could still have the same lengths of the sides. So for example, if this was 3 and this was 4, let's pretend that's a rectangle. That's what it looks like. This could easily shift into a parallelogram with the same dimensions. So what prevents it from shifting? Well, that support does. But the reason the support helps is because it's making triangles. And triangles are stable, rigid shapes. Quadrilaterals are not. All right, let's look at this proof. We have two triangles and they give you segment AE congruent to segment CE. They also tell you that segment AB is congruent to segment CD. And they tell you that point E is the midpoint of segment BD. So the two pieces of given that they gave you that are congruent statements I have marked. So I'm just going to do this to kind of cheat, save myself some time and some writing. That's given information. So you have two pairs of congruent parts. Now, the other thing, this E being the midpoint of segment BD, that is a completely different concept than two congruent statements. So I'm going to write it out. E is the midpoint of segment BD. That's given also. But again, I separated it because they're different concepts. Now I can just focus on this piece of given. If something is a midpoint, remember what that means. And if they give you a term here, remember what you should be doing. You should define what that term is. So you better say what a midpoint means. What is a midpoint? If E is the midpoint, what do you know about these segments? I know these segments are congruent. So segment BE is congruent to, watch my order, BE goes with segment DE. So those segments are congruent because E is the midpoint. Now look at your triangles. You have three pairs of congruent parts. Is it possible for those triangles to be different if you have three pairs of congruent parts? It's not possible. They have to be congruent triangles. So triangle EAB is congruent to triangle ECD by side.